All right, ladies and gents, I am here ready to answer any questions that may come my way. Remember, to answer a question, all you have to do is type it into the comments box, and I will receive a notification probably within a couple of seconds on my email that you've asked a question, and I will go ahead and answer it. I'm going to be using a Word doc with my tablet to go ahead and answer any of the questions that I receive. So if you are watching this video later to study, what I'll do is I will write the question that I receive before I answer it in black. And then I'll use a different color to go ahead and write that answer. So as you are looking for a specific topic, you can just scroll through the video and look for the question that you may have. So we are just waiting for our first question. And I hope that those of you that are watching are joining us have things that you would like answered. Otherwise, you're just going to be looking at me look at you. So that's where we're at. Just waiting for a question to come my way. Bill, this is kind of awkward. Right. So they should be able to type me questions. And right now it is just me staring at my computer screen waiting for a question.
Are you on a tape delay?
Yeah, so it's like a 20-second delay. I don't know what to do. Stop being so awkward. This is recording. It's going to go on my YouTube channel. Right now, it is just me staring at my computer screen. Perfect question. Like, this is you coming in? Yeah, it's like a 20-second delay. I'm just like smiling. Stop being so awkward. This is recording. It's going on my YouTube channel. I should probably mute that.
You should press one.
Yes, I muted so I have the YouTube up so I can see if anyone like types a comment in or a questioning.
You missed the canoe.
Yes, I missed your canoe. There are 8 people watching, so if any of you 8 people have a question, please feel free to type it in the comment box. I'll be more than willing to answer the question that you have. Just waiting for that first question to come. I wonder if I've done something wrong where they can't. If you are watching and you cannot type in the comment box because this is something I'm not certain that might be the issue, open up your email and shoot me an email question and I can get it to you that way. Or maybe you can click join and just join in and somehow pop up on the screen and ask me a question. I'm really not certain if this is going to work. We'll find out. Hey, Bill. Oh, I can find it on my, I can find it on the iPad. And the kids are just watching me do this on my iPad. This is probably super awkward for them. Oh, I got an email. We have our first question. I'm all excited. All right, our first question is, All right, so we have our first question about when we talk about MAVABA. So I'm going to go ahead and start to answer this question for our student. So this is talking about why when you increase the molarity of the base, the concentration is going to be impacted. So if we think about why is molarity impacted? Oh, you can't see this because I'm not sharing the screen with you. Sorry, I'll get better at this as we go. All right, here we go. Share. So you shall be able to see my screen. So why is molarity impacted when the volume of base is changed? So if we think about the MAVABA equation, and for Mrs. Staub students who are watching, I do teach MAVABA a little bit differently. I teach it with the mole ratio being on the acid side. If we think about how we solve for this variable, so if we're doing this math problem here, this is specifically relating to the titration lab. If I know all of these numbers based on the information that I got from the data in the lab, if I accidentally overshoot, that means I'm going to be adding more base to the titration than I needed. So I am actually making this number higher than it should be. So if we think about algebra, when we're solving for the molarity of the acid, we're actually dividing it by this is the algebra that we're actually doing to solve the problem. So if I'm making this number larger, what that means is I have a bigger number on top of my fraction. So since this number is larger on my fraction, my overall molarity of my acid is going to be increased because it looks like more base is needed to neutralize it. So if I'm using more base to reach my equivalence point, that must mean my acid has a higher concentration. So I hope that you found that helpful in terms of your answer. So that was to Natalie. All right, our next question comes from Michael. What are the main characteristics of acids and bases? So this is going to be a really easy one. This goes back to the lab we did before spring break. So if we think about the lab that we did before spring break, we know that acids are going to be defined as things that produce H pluses. So how we can see that in a lab setting is they're going to be things that are going to conduct. They're going to react with indicators. And if you remember from the lab, when we put baking soda in, when we put that white powdery stuff, we saw lots and lots of bubbles. So they'll bubble with baking soda. And they'll react with metals, which is what we also saw in the lab because they made the metal actually bubble and disappear. Now, some other things about acids that you may want to know is they're going to be very, very sour in terms of how they taste. Not that we'd ever taste anything in a lab, but they do taste very sour. And they're also going to be, no, I think that's everything. I was going to talk about bases next. So that's going to be everything. So this is the main characteristics of acids. If we talk about bases, oh no, I'm running out of room. So if we talk about bases, bases are going to produce OH minus. So that's going to be the big thing they do. Or they accept an H plus. And from the lab, some things we saw they do is they also conduct. They will also react with indicators. But they will not bubble with baking soda and they will not react with metals. So those are the things that are specific to acids only. What they will do is they react with organic material. And they will turn red litmus blue. And that was that paper that we saw that was just kind of like in that really old looking tube from the lab. So they turn red, litmus, L-I-T, I'm misspelling that. Sorry, my handwriting's not the best, guys. I'll get better. And then I guess your acids, I forgot this, they turn blue, litmus, red. So if you were to have a data table type question on the test tomorrow and you're trying to figure out what the difference was between an acid or a base, these would be kind of the things that you would want to look for. And this is very similar to the full sheet I gave my classes and the half sheet Mrs. Staub gave her classes to go ahead and practice this. All right, so Michael, I hope that helped you out there. Our next question comes from Naveen. It says, what is the difference between an Arrhenius acid and a Bronsted-Lowry acid? And Naveen, I'm here to help you understand that there is really not much of a difference between those two things. When we look at the definitions, Arrhenius an Arrhenius acid is what we call H plus producer. So they're going to produce H plus. So when they're dissolved, they're going to produce an H plus, and all Bronsted-Lowry says, and I'm going to shorten that as BL just for sake of writing, they are going to be H plus donors. So when we think about those two definitions, they're really not that different from one another. Saying you're producing an H plus or you're an H plus donor really isn't that different. The big thing about your acids is all the formulas are going to have an H in front of whatever anion you have. So HCl, HC2H3O2. Those are all things that are going to make H's when they dissolve. So there's basically no difference in definitions. They're just saying the exact same thing. So Naveen, I hope that helped you. All right, on to our next question. Our next question is taking a second to load. Sorry there, guys. Our next question is about drawing the pictures for the titration. So I can definitely go ahead and give you some help with that. So we're going to talk about titration pictures next. So titration pictures, what you have to do is you have to think about what part of the titration is it asking me for? Is it asking me for the start? Is it asking me for the middle? And is it asking me for the end? So if we think about a titration to start, they're all starting with solutions. And in the beaker, you'll have your acid, and in the burette, you'll have your base. So in the beginning, all of my base, so in this case, we're just going to use NaOH, is in the burette. And all of my acid is going to be in the solution. So if I think about like HCl, I did not make my beaker big enough. Sorry, guys. It's going to be nothing but H pluses and Cl minuses. So at the beginning of my titration, all I have in my beaker are just acid particles and its anion. So that's all I really have in my beaker to start. When I'm part of the way through my titration, what that means is I've actually added the NaOH into my container. And we know that when acids and bases react, they make water. So if we were to write the reaction for this titration, our HCl plus our NaOH is going to make water, which we can write as HOH and sodium chloride. So if we think about how we're going to draw this picture that's maybe halfway through, so something that's in the middle, what that would mean is half of my H's would have reacted to make water, and half of my H's would still be for HCl. So in my picture, I would have 2 H pluses, because I started with 4. I would have 2 water molecules, and then I would have 2 Cl's, or sorry, I would still have my 4 Cl's, because those don't really react with anything. And I would also have 4 NAs, but I'm not going to have room for that, so I'm just going to put that over here because I didn't make my picture high enough. Would also be in that, or sorry, not 4 NAs, only 2 NAs would be in there, because I would have half of my acid reacted, which means I would have added 2 NAs to react with 4 of my H's. At the end, what that means is I would have none of my acid left because at the end point, all of my acid has reacted. So in my picture, I would have 4 waters I would have no acid particles left because they would have all reacted to form water, and then all I would have was my NaCl pieces. So I would have 4 NAs at that point, and I would have 4 Cl minuses. But I, again, did not make my picture big enough. So basically, when we're drawing these titration pictures, what happens is when we start, we have only the acid in our beaker. As we go through the titration, we add the base. So the OHs can react with the H's to make water. So halfway through, half of my acid would have reacted and half of my acid would remain. And then at the end point, all of my acid would have reacted to make water, and I would have however many Cl's and NAs as I need. There should be a plus sign, sorry, as I would need to go ahead and make that that picture neutral at the end point. So Lindsay, I hope that helped. For those of you who are maybe just starting to join the Hangout, some people are having problems answering questions in the comment section because they don't have an account. So if you don't have an account and you would like to ask a question, please go ahead and just email it to me. My email, I'll write on the screen for those of you that are not my students. shannon.etnier@d128.org. So those of you who are maybe having issues putting comments in the comment box, go ahead and feel free to shoot me a question that way. I received a question from one of my students asking about the test. I'm not sure if he's watching or not right now, but one thing I had mentioned is that for my class specifically, and I can't speak to Mrs. Staub's class, that yes, there's going to be data tables on the test for you to interpret. So we've done a lot of labs in this unit, and so you will see very similar data tables to the ones you've created on your labs. So for the buffer lab in my class, there's going to be a data table with different numbers of drops and colors for you to interpret the strength or sorry, the buffer capacity of a buffer per se. Or there might be, if we go back to this question here, there's definitely going to be a data table that kind of talks about some of the characteristics of acids and bases. So you'd have to interpret that to determine is a substance an acid or a base. There's going to be data tables to determine how you do the titration calculations, just like the titration lab. So there's definitely going to be data tables on this test. So please make sure you look at your labs as you're studying, not just focusing only on just what you see in the review packets. Make sure you are looking at that. And I'm going to pull up the YouTube right now to see if there are any questions that I have missed right now. So we'll go ahead and see what's happening. All right, and as of right now, I have answered all the questions I'm seeing in the comments section. So if there is something else that you are curious about or wondering about, especially if it's on maybe the review packet I provided in class today or something from notes, please feel free to either shoot me an email or put your question in the comment section of the video, and I will answer it as they come up. And for those of you that are watching, I hope that you're finding this useful. It's definitely an interesting experience. So keep those questions coming. For those of you who may be watching who don't have a question right now, I'm trying to think of some things that you might want to consider looking at as you prepare for the test, just to kind of keep it moving while we wait for the next question to come. So definitely things you want to make sure that you're aware of. We've already reviewed a little bit here, characteristics of acids and bases, and just in general, what makes something an acid versus a base. Remember, acids are going to be H+ donors and bases are going to be OH- acceptors. You definitely want to be able to understand how to determine if something is a conjugate acid and base pair. So if you have a question on that, please feel free to type it in and I can help you with an example or two. You want to be able to use that square of awesomeness. And remember, you do get the square of awesomeness on the test. We do not make you memorize that. So all you have to do is be able to use that square effectively. And remember, if you are uncertain of, did I put this in my calculator right? I will definitely help you out with that. You can raise your hand during the test and I'll make sure that you definitely have it entered. And it looks like we might have had another question that popped up here. So let's see what we got here. All right, this one is about titration of a weak acid, and this is something that we don't cover in regular chemistry. This is something that is more geared towards honors chemistry, and I believe that, Natalie, you are one of Mrs. Staub's students, so I am not certain if you're a reg student or honor student, but I'm more than willing to answer this question for you guys. So let's go ahead and let's get started. Okay, so this is going back to the idea of I have put too much base in. Let's go ahead and start a new page. So this is talking about weak acid titration, which if you're a reg chem kid, this does not apply to you. This is for the honors kids who might be watching right now. So if you're a reg chem kid, feel free to kind of disregard this. So titration of a weak acid. And reg chem kids, I will tell you when to start paying attention again, because one of the questions she does have is about the endpoint, which I will definitely address here in a second. So if I'm titrating a weak acid, as we know, weak acids like to stay stuck together. So if I'm looking at the titration equation, so let's say I'm using NaOH to titrate a weak acid, so something like acetic acid, which is HC2H3O2. We know based on our acid-base problems that the positive switch spots, so my +1 Na and my +1 H are going to switch with each other. So I'm going to have NaC2H3O2 and water, which is HOH. Now in regular chemistry, we just said, hey, this is going to equal an equivalence point of 7. So for regular chemistry kids, that's all you really need to know. For honors chemistry kids, that's not necessarily the case. Because this salt remains aqueous in water, when we're titrating, we get these Na and C2H3O2 ions that are floating in the water. Now the Na is not going to interact with water, but the C2H3O2 is. That anion is going to go ahead and it's going to react with water in a way that it's going to get its H back, because this is a slightly reversible reaction. So we're going to reform that acetic acid particle and make a little bit of OH minus ion in the process. So when we actually reach the equivalence point for the titration of a weak acid, we're going to have a slightly basic pH at our endpoint. Because when we have equal moles of H and OH that have been added, these sodium acetate particles are actually going to react in a way that recreates a little bit of this acetic acid, leaving these OH minus ions behind. So this is going to shift our endpoint basic. So Natalie, I hope that answers the titration of a weak acid question. Now I'm going to go ahead and I'm going to talk about the what happens if you run past the endpoint question again. And I'm going to try and do this by drawing a picture. So we know from our titration lab, so reg chem kids, pop back in and pay attention. So we know from our titration lab that we put NaOH into a container that had some acid into it. And we know that when it turned a nice light pink, ooh, do I have a pink color? Let's see. More ink colors. Nope, not an option. We're going to choose this nice light color. So we knew that when it turned this nice light pink color that we had reached our endpoint. So that was the perfect spot where our concentration of our H plus and our concentration of our OH minus were equal to each other. And so that meant we had a pH of 7. So when we think about the Mavaba equation, at that point, we could go ahead and we could solve for our unknown variable, which is the molarity of the weak acid. So let's just say, to show you guys a little bit of math, that the volume of the acid that we started with was at 5 milliliters from the lab. Our mole ratio was 2/1, like for the sulfuric acid. The molarity of our base was 0.15, and let's say that it took us 10 milliliters, just for easy calculation purposes. So we could solve for the molarity of our acid in this situation. Let me grab a calculator real quick. So we would do basically 0.15 times 10. So we would do 1.5 divided by 10. So we would get the molarity of our acid to be 0.15. Now we learned that if we overshoot, our solution turns bright pink. So we get this crazy fuchsia color. And then Mrs. Staub and I would yell at you that you guys overshoot, and then we would laugh at you, and it would be great times. So in the event of an overshoot, what that means is you add too much base. So let's pretend that we were only supposed to get 10 milliliters, maybe we got 20 milliliters instead. So if we redid that math, we would be doing 0.15 times 20, and then we would divide that by 10, so it would be 0.3. So in that case, we would be ending up with a higher molarity. And Natalie, I hope that helps. And I understand there's an issue with my screen sharing right now. Apparently you guys can't see what I'm screen sharing. So let me try again. And let me check and see if this is going to fix the problem. Natalie, I'm so sorry. Thank you for giving me that heads up. Let's see if this has fixed the problem. And I can see from, I just pulled up YouTube on my computer, that the only thing you guys can see is my face. So let's see if this has fixed the problem. Okay, now you can all see the drawings that I've been giving you, and I am so sorry. Natalie, thank you for letting me know that you have not been able to see this sooner. So let me go ahead and let me re-go through some of the questions that I've received tonight. I am so sorry for not being able to do this sooner. Natalie, thank you so much. So things I've been asked so far is main characteristics of acids and bases. So acids, we learned in the lab, they're going to be great conductors. They're going to react with indicators. They're going to bubble when we put baking soda in them. They're going to react with metals, and they will turn blue litmus red. Bases, they are also going to conduct. They'll react with indicators. They will react with organic material like our bodies. They will turn red, and they will turn red litmus blue. Other questions I've been asked are the difference between Arrhenius acid and Brasylori acids, and there's really no difference because Arrhenius says we produce H+, while bases say we're H+ donors, and basically all that means is we're an acid with an H in front that will be given off when we dissolve. Lindsay, this is for you. This is your titration practice picture. Again, I'm so sorry. I didn't realize this was not being shared properly. Your titration pictures, remember when you're starting, that means all the acid is in your beaker and the base is going to be in the burette. So initially when we draw it to start, we're only going to have acid particles present. As we go through our titration, we're adding NaOH into our beaker. So what that means is some of our acid particles are going to react with the OH minus from our base to make water. So if I'm halfway through, if I started with 4 particles, halfway through, half of them would have reacted. So I would have 2 waters for 2 of my H's that have reacted and 2 H pluses remaining in the solution. At the very end point, when we've reached that neutral solution, all of my acid would have reacted to make water, and then all I'm left with are the NAs and the CLs that were once with my acid and my base. This is my email again. Remember, if you can't comment, this is the easiest way to go ahead and shoot me an email. And this is the latest question that Natalie just asked me, the terms of the titration of a weak acid. So Red Kempkins, again, tune out for just a second, and then we'll bring you back here in about a minute. So if I'm titrating a weak acid, what's happening is my OH is grabbing my H to make water, just like a normal acid-base reaction, and my Na will combine with the anion, which is in this case acetate. Now, because acetic acid is a weak acid, what that means is this anion does not like to be without its H+. It's like a clingy girlfriend who needs her boyfriend back. So that acetate ion will actually react with the water that's made on the product side to make the reaction go backwards to reform the acid particle along with some OH minus ions. So when you reach the endpoint of a weak acid titration, your endpoint is not 7, it's actually going to be a little bit basic because this acetate ion keeps grabbing the H's from the water to make OH minus ions. All right, and this one's for everyone. This is going to the what happens if I run past the endpoint. Now we remember that it turns bright, bright pink when we overshoot. That means we've added too much base. So if the perfect titration only required 10 milliliters, our molarity would be 0.15 because my variable's on the left. So when I do my math, I would do 0.15 times 10 is equal to 5 times 2. So I would divide my 1.5 by 10 to get 0.15. But if I overshoot, that means I add too much base. So what that means is I've made my base volume too large. So maybe I overshot so much, I put 20 milliliters of base in. So I like doubled how much I should have put in. When I do the math this time, and I do 20 times 1.5 divided by 10, my molarity is 3. My molarity is going to be a lot bigger because my top number in my algebra problem, the top number in my fraction is a larger number. So if I have a larger number on top, my answer is going to end up being larger. So Natalie, thank you so much for the heads up that you couldn't see my Word document. I hope that this has helped clarify some of the questions you guys had. And remember, keep those questions coming as you have them. I am so very sorry that it took me so long to realize that, guys. I feel really bad. But I hope you're finding this helpful. I hope you know that this is helping you review, and please keep those questions coming. If you do have any questions, remember you can just comment in the space below this video, or you can shoot me an email and I'll get back to you. I'm going to be live for about another 15 minutes answering the questions that you guys have. Things I've talked about if you're just joining the video is you definitely want to make sure that you are familiar with the labs for this test because there will definitely be questions from those labs on the exam itself. I have another question that I will gladly answer now. Someone just asked about the products of titration reactions, and this is a great question. They said HOH will always be a product in the titration problems, right? Absolutely. Anytime you're doing titration of any acid, whether it's strong, weak, whatever, it's a double replacement reaction. You will always be reacting a base with an acid. And because of that, one of your products will always be water. How you figure out the other product is by looking at the positive and negative ions that you're reacting. So if we did another example here, so if we did just another example of a double replacement reaction that wasn't that easy, so let's say maybe we were looking at an H3PO4 example. Plus maybe a potassium hydroxide this time, just switching it up. What we would want to do when we do the double replacement is we want to figure out the ion charges first before we go ahead and actually do the double replacement reaction. So we know H's are a +1 because they're in column 1, and PO4 is -3 in the back of your periodic table. K is a +1 because it's in the first column of your periodic table, and OH- is a -1 on the back. So our positive pieces are going to switch partners. So my K is going to go with my PO4, so I'm going to have a KPO4 compound. But because my PO4 is a -3 and my K is a +1, I need 3 of my Ks. My H is a +1 and my OH is a -1, so my product will be HOH. So like Corey asked, yes, you will always get HOH as a product. Now what we do is we balance because of these subscripts. So because I have 3 H's on this side, I put a 3 in front to balance my H's. I now have 3 OH's. So I put a 3 in front of my KOH, and I have 3 Ks that are balanced as well. I've got 1 PO4, 1 PO4, and I am now balanced. So Corey, I hope that helped you out with the answering of that question. So some of you guys who are watching now, I see we have a couple of people who just kind of joined into the video. If you have any questions, you can either write them in the comment box below, or if you do not want to write them because you don't have an account, you can email them to shannon.etnier. Oh, that's not how you spell my name. And while I'm waiting for a couple more questions to come, I'll be live for about another 10 minutes. Things that I can think of that you guys would definitely want to be aware of before taking the test tomorrow. Like I said, you do not have to memorize the square of awesomeness. You just have to be able to know how to use the different calculations. So if you're going up between pH, or so if you're going up between H plus and pH, you want to follow the up arrow. If you're going down, you want to follow the calculation that's on the down arrow. For the titration equation, we do not give you MABA. That's the only thing we ask you to memorize. When you're talking about buffers, remember you just have to memorize those 3 strong acids. Those strong acids, you definitely want to make sure you know that you've memorized, because these can never, ever, ever be a part of a buffer. Are HCl, which is hydrochloric acid, H2SO4, which is sulfuric acid, and HNO3, which is nitric acid. So those things can never, ever, ever be a part of a buffer system, because buffers must have weak acids in them. So these are the acids you want to memorize, because if I was to ask you, hey, is this a buffer? And you see any of these options, it would not be a choice. You definitely want to know the difference between monoprotic, diprotic, and triprotic acid. Monoprotic acid is one that only has one H in front, which is HCl. A diprotic acid would be one that has 2 H's, like H2SO4. And a triprotic would be an acid that has 3 H's, like H3PO4. I see we got another question coming in, so let's go ahead and give that a quick look. All right, I've got a question about conjugate acid-base pairs. Absolutely, I can go over some examples of conjugate acid-base pairs. Let's go ahead and choose a different color. All right, these questions can come in a couple of different ways. So I'm going to go through both of the examples of the ways that we could go ahead and give you questions on this. So one thing we could do is we can give you a chemical reaction. So I'm going to write 2 reactions down here. All right, so in a question like, oh, that wouldn't be a 4. So in a question like this would be something where we would give you the chemical reaction and we would ask you to identify what the conjugate acid-base pair is. So a conjugate acid-base pair is going to be the linkage of 2 things by the loss or gain of an H+. And I know that's kind of confusing. So when you look at this reaction, what you want to do is you want to figure out, okay, the HF is together on this side. There's an F by itself on this side. So these 2 pieces must go together. And here I've got H2O and H3O, so those 2 pieces go together. So what I've done first is I've linked up the pairs. So now how we determine what's the acid and what's the base. Acids are always going to have H's in front. So in this case, this would be your acid, which means your water has to be your base because it is accepting an H. So your acid is going to lose an H, your base is going to gain an H. So how we determine what's the conjugate acid and what's the conjugate base is your acid is always going to turn into the conjugate base on the reactant side. Your base will always turn into the conjugate acid. So you'll always link up the acid on the reactant side to the conjugate base on the product side, and the base on the reactant side, conjugate acid on the product side. So if you look at this example down here, my NH3 turns into NH4, and my H2O turns into my OH minus. So now we just have to figure out what's the acid and what's the base. In this case, because my NH3 is going up by 1 hydrogen, that means this is taking a hydrogen in. So it's the hydrogen donor, or sorry, the hydrogen acceptor. So it's going to be the base, which means my water is going to be the hydrogen donor. On the other side, if we look at the opposite side, because this is my base, that means my NH4 must be the conjugate acid when it goes backwards, so it must lose an H, and the OH minus must be the conjugate base. So this is one way we can give you a question. Another way we can give you a question is we can give you a bunch of examples, and we could ask you to determine if it is a conjugate acid-base pair. So I could give you something like H2O and OH minus. I could give you something like H2PO4 minus and PO4 3 minus. And I could give you something like NH3 and NH2 minus. So these are some different examples of ways that we can give you the question on the test. And we could say, is this a conjugate acid-base pair? Or like pick out the conjugate acid-base pair. So what you want to do is you want to figure out that if I take an H away from one of the compounds, would the two pieces match? So anytime I see water, I like to rewrite it as HOH. And so if I think about it, if I was to take this H and remove it, this OH would match the OH in the problem. So yes, this would be a conjugate acid-base pair. If I look at the example here, if this NH3 loses an H, it goes from 3 H's to 2 H's. So those two pieces would match, because if we take away a positive, it would become a negative. So yes, that would be a conjugate acid-base pair. If I look at these two examples, if I was to take away an H, it would go from 2 H's to 1 H. So this would not match this. So no, this would not be a conjugate acid-base pair because it's lost too many H's. You can only be a conjugate acid-base pair if you're losing or gaining one H at a time. So I hope that you found this helpful in determining conjugate acid-base pairs. So I'm going to be live for just a few more minutes. So if you do have a question, please feel free to write it in the comment box. Get that last second question. I'll definitely stay as long as I have a question. But if I don't seem to get any more here in the next couple of minutes, I will be ending this broadcast. Sorry again for the issue in the beginning where you couldn't see my screen, but I hope now that you've seen the screen that this has been a little bit more helpful and beneficial. And remember, this link will be posted on this YouTube channel. It will remain as a broadcast. So you can come back to it later tonight as you're studying, and you can watch some of the information that has been discussed through your studies. I know this wasn't organized in the best way possible in terms of where answers are going to be found. So we'll try and do better next time. But if you are watching, if you could let me know if you found this helpful, either tomorrow in class, or just shoot me an email and say, yes, it was great, no, it wasn't great. If you have comments or feedbacks about how to make it better next time, in terms of organization for you to be able to watch in the end, I am definitely welcoming any and all suggestions, as this is my first attempt at something like this. So if you happen to have any questions before I sign off, please feel free to shoot me an email or type them in the comment section. I'll be live here for just a few more minutes in case we do get that last second question. If we don't get that last second question, or you don't get it in before I stop my broadcast, remember you can always email me tonight. I will be checking my email periodically still throughout the evening, and I'll also be in school early tomorrow morning. So I guess we can go ahead and turn this off right now because I don't really have a question yet. So if you do have a question here, real quickly before the end, I am going to sign off here in a minute or two. So if you have something, get in and out. Otherwise, I hope that you found this helpful. And I know you guys are all going to do great tomorrow. So yeah, any last minute questions before I log off? I see we got 10 people watching. I feel pretty accomplished. All right, it doesn't seem like we're getting any more questions before the end of this broadcast, so I'm going to go ahead and get some planning done for our next unit, which is all about chemical reactions. Woohoo! So if you do have a question that wasn't answered, please feel free to shoot it to me via email tonight or swing by the room tomorrow morning. I will be there answering any and all questions that you guys do have. I hope that you found this helpful and useful, and I'm definitely looking for feedback about how you thought this went and ways I can improve it for next time. So now obviously have your screen up the whole time, so you're just not watching me talk about an answer. I get that. But if you have any questions at all and it was not answered, please feel free to email me or swing by in the morning, guys. Thanks for joining me tonight, and I wish you good luck and have a great evening. Goodbye.